So what happens when humanity faces its darkest hour? Like a truly devastating plague.
Right. Do we just despair?
No.
Or do we find a way to create something, to connect?
Maybe tell stories.
Exactly. And that's what we're diving into today. Giovanni Boccaccio's The Decameron. It's this incredible collection, 100 tales, all framed by a really gripping real-world event.
Okay, so our mission for you today is to really unpack this. It's such a foundational work of Italian prose.
Absolutely. We want to look at its, well, surprising origins, the themes that keep popping up, and just how incredibly influential it's been.
Yeah, show you why it's so much more than just some old historical text. What's amazing, really, is how this book, born from such a crisis, still resonates hundreds of years later.
It really does.
So to get into the Decameron, we kind of have to set the scene, don't we?
We do. You need to picture 14th century Italy, Florence specifically, and it's in the grip of the Black Death. Just horrific.
And this isn't just background noise, it's the catalyst, right, for the whole thing.
Totally. The core idea is this group, 7 young women, 3 young men, they flee the city because it's just ravaged by plague.
Smart move. Where do they go?
They escape to this secluded villa out in the countryside, Fiesole. They plan to stay for 2 weeks, just trying to, write it out, find some peace.
And their plan to pass the time.
Yeah.
Well, that's where the book comes from.
It is. It's quite ingenious, really.
Yeah.
Each evening, one person tells a story.
How did they organize that with 10 people?
They had a schedule. They set aside 1 day a week for chores, practical stuff. And holy days were off limits for work or storytelling. So that leaves 10 days over the 2 weeks specifically for telling stories.
10 days, 10 storytellers each night.
Exactly. 100 stories. Boom.
Simple math, brilliant structure.
And it gets more structured. Each day, one of the 10 acts as king or queen.
Like in charge for the day.
Kind of.
Yeah.
Their main job was choosing the theme for that day's stories.
Oh, interesting. What sort of themes?
All sorts. The power of fortune, luck changing suddenly, human will, love, both tragic and happy endings, clever comebacks.
Practical jokes, too, I bet.
Oh, yeah. Tricks women play on men, tricks people play on each other in general, even stories about virtue. It gives you a real window into what they talked about, what mattered to them.
But wasn't there one character who didn't have to stick to the theme?
Yes. Dionio. Good point. He usually tells the last story, the 10th one each day.
And he gets a pass.
He does. He has the special privilege of choosing any topic he wants. Which is interesting because a lot of scholars think Dionio might be Boccaccio's own voice, in a way.
Like expressing the author's maybe more controversial ideas.
Possibly. It's a theory. He often pushes the boundaries a bit more.
Okay, so we have the stories, the themes, the structure. What about the rest of the book? It's not just the tales, is it?
No, not at all. The frame itself is really rich. Between the storytelling sessions, Boccaccio describes their other activities at the villa. Walks, meals, music. He even includes the words to Italian folk songs they supposedly sang. It makes the whole thing feel very complete, very immersive.
Right, like you're really there with them. So looking at the 100 tales themselves, what are they actually like?
Oh, they're incredibly diverse, a real mosaic. Some are definitely erotic, quite explicit for the time. Others are deeply tragic.
But also funny.
Absolutely. Lots of wit, practical jokes, as we said. And many offer these little life lessons embedded in the narrative. What's really striking is how unflinchingly they show human nature.
So what kind of picture does it paint of the society back then?
A really vivid one. You see these recurring plots, recurring themes. For instance, there's a lot of mocking the clergy, their greed, their lust. It's quite biting.
And women, how are they portrayed?
Interestingly, female desire, female ambition. It's often shown as being just as strong, just as present as male desire and ambition, which feels quite modern in some ways.
What else comes through?
You really see the social tensions of the time, especially between the rising merchant class, the new money, and the old noble families.
Classic conflict.
Exactly. And lots of stories about traveling merchants, their adventures, their perils. It's a document of life.
Yeah.
Shows you the norms, the humor, the morality of the 14th century.
It sounds like more than just entertainment then. It's social commentary.
Definitely. It's a raw, sometimes uncomfortable, but always fascinating mirror to human experience, both the good and the bad, proving, I guess, that people don't fundamentally change all that much.
Okay, Beyond just reflecting society, does the Decameron have deeper meanings, philosophical layers?
Oh, absolutely. There's a philosophical outlook that kind of ties it together. One big theme is the whole medieval idea of Lady Fortune.
The Wheel of Fortune.
Exactly. That idea that your luck, your status, can change in an instant. You can rise high, fall low, all based on things outside your control. It pops up again and again.
And Boccaccio knew Dante's Divine Comedy, right, which is heavy on allegory.
He did. He was educated in that tradition. But unlike Dante, who used allegory mostly to teach, to guide, Boccaccio often uses it, or seems to use it, to satirize.
Satirize what, specifically?
Well, the Catholic Church gets hit pretty hard, priests, religious beliefs. The satire reflects this sort of widespread disillusionment, especially after the trauma of the Black Death. You can feel it simmering under the surface.
Right, people questioning things. And I heard there's something about numbers, numerology.
Yes, that's common interpretation.
Yeah.
Medieval thinkers loved finding significance in numbers.
So the 7 women.
They're often seen as representing the 7 key virtues. The 4 cardinal ones, prudence, justice, temperance, fortitude, and the 3 theological ones, faith, hope, charity.
And the 3 men.
They're thought to line up with the classical Greek idea of the soul having 3 parts: reason, spirit, and appetite. Basically, the rational mind, our emotions, and our basic physical drives.
Does Boccaccio say this directly?
He does say their names, Pampinea, Fiammetta, and so on, are pseudonyms. He says he chose them because they're appropriate to the qualities of each.
So he's hinting at it.
He is. But it leaves you wondering, doesn't it? How deep are we meant to dig into all this symbolism? Or should we just enjoy the stories? Maybe it's both.
Okay, let's talk about where these stories actually came from. You mentioned he borrowed.
Oh, massively. Boccaccio was, let's say, a masterful borrower. He took the plots for almost all his stories from earlier sources.
Really? All of them?
Pretty much.
Yeah.
Just like later writers, like Shakespeare, would borrow heavily from him.
Where to get them from?
All over the place. French stories, Italian ones, Latin texts, but also further afield, India, the Middle East, Spain. Some of these tales were centuries old already.
Like that story of Andruccio of Perugia.
That's a great example. Its roots go back to a tale from Ephesus in the 2nd century. Incredible reach.
Even his description of the plague. You said it was based on something earlier.
Yeah, even that part, which feels so immediate because he lived through it, seems to draw on an 8th century description by Paul the Deacon.
Wow. And he drew on classical writers, too.
Definitely. Ovid was a huge influence. People even called him the Italian Ovid.
But he wasn't just copying and pasting.
No, absolutely not. That's crucial. He wasn't just transcribing. He made these stories his own.
How?
Oh, he updated them, set them firmly in his own 14th century, made the details, the settings, the language feel contemporary to his readers.
And he mixed things up.
Yeah, he often skillfully combined 2 or even more completely separate older tales into one single new narrative. Like in stories 2, 2, and 7, 7. It shows real craft.
And he put real people in them.
He did. You find actual historical figures wandering through the stories. Famous artists like Giotto, poets like Guido Cavalcanti, rulers like Saladin or King William II of Sicily.
Wait, even those tricksters, Bruno and Buffalmacco?
Yes. Scholars have actually found records suggesting they and their poor victim Calandrino were real people in Florence at the time.
That's amazing. So it's like early historical fiction.
Kind of. And then there are characters who seem fictional, but are clearly based on real contemporaries, like a character named Madonna Fiordaliso, who seems based on a real Madonna Flora. It adds this layer of gossip almost.
Did he care about historical accuracy otherwise?
Not always, it seems. He'd intentionally mix up historical facts or geographical details if it served the story better. Narrative trumped strict accuracy.
Makes sense for a storyteller.
And he really developed the characters. Through their dialogue, their actions, they feel real, and what they do feels logical, even if it's outrageous within their world. He often made existing simple tales much more complex, psychologically richer. Tale 9x6 is a good example. Chaucer used a version of it too.
So a brilliant collection, hugely popular. But it caused trouble, didn't it? Especially with the church.
Oh, definitely. That anti-clerical streak we mentioned, mocking priests and monks, that did not go down well.
So attempts to suppress it.
Yes. Early on, back in 1497, this firebrand preacher, Girolamo Savonarola, led a bonfire of the vanities in Florence.
Burning books and luxury goods.
Exactly. And the Decameron was one of the books thrown onto the fire, deemed immoral.
And later it was officially banned?
It was. In 1559, Pope Paul IV put it on the Index Librorum Prohibitorum.
The official list of forbidden books.
That's the one. Anathema to the church, effectively banned for Catholics.
But did that work? Did people stop reading it?
Not really. It was just too popular. It kept circulating, kept being read, kept growing in influence.
So what did the church do then?
This is fascinating. They actually commissioned revised versions. Pope Gregory III ordered one in 1573.
Revised how?
The editors basically went through and changed the problematic bits. So if a priest or monk was doing something scandalous in a story, they'd change him into a secular person, like a professor or a nobleman.
Seriously? Just swapped him out?
Yep. And apparently even that wasn't enough for a later pope, Sixtus V. He commissioned another revision, the Salviati edition, in 1582.
Wow, it really says something about the book's power, doesn't it? That they felt they had to change it rather than just ban it.
It really does. They couldn't ignore it, so they tried to reshape it.
What about translations? Especially into English.
Well, they started happening, but for a long time, English translations were careful, often incomplete.
Meaning they left stuff out.
Yeah, they'd omit the racier tales or passages considered offensive. Things like Story 3X or IXX, even hints of homosexuality, like in VX, were often modified or cut entirely. Translators faced real challenges for centuries.
So when did a full English version appear?
The first one considered truly complete, warts and all, was by John Payne in 1886.
That late, wow.
Yeah. And even then, the effort continued. George Henry McWilliam did the first really contemporary one in 1972. And there are even more recent ones, like Wayne Rebhorn's from 2013, described as strikingly modern. People are still trying to capture its voice.
Was it influential in other languages, too?
Hugely. Petrarch Boccaccio's friend made a Latin version of some stories, particularly the last one, the Griselda story.
And that Latin version spread?
It did. It influenced many early translations across Europe. The very first foreign translation we know of was into Catalan, way back in 1429, then French, Spanish. It really took off.
Okay, this might be the most amazing part. The adaptations. It seems like everyone borrowed from the Decameron.
It's incredible, isn't it?
Yeah.
The sheer breadth of his influence across different art forms is just staggering.
Let's start with theater. Shakespeare.
Yep. All's Well That Ends Well is based on Story 3:9. Parts of Cymbeline draw on 2:9.
Who else?
Lope de Vega, the Spanish playwright, adapted at least 12 stories. Molière in France used plots for L'École de Marie and Georges Dandin. Gotthold Ephraim Lessing used the parable of the three rings from a sea, 3, in his play Nathan the Wise. Even Tennyson wrote a play based on one.
Okay, that's huge. What about prose writers?
Martin Luther retold Story 1:2, the one about the Jew who converts because he sees how corrupt the church is in Rome. Jonathan Swift drew on it. Charles Perrault retold the Griselda story.
And poetry. I know Chaucer used one.
Yes. The Clerk's Tale in the Canterbury Tales is the Griselda story, likely via Petrarch's Latin version. John Keats wrote Isabella, or The Pot of Basil based on Fifi 5. Shelley used the story. Longfellow, too.
Music. Did it get into music?
It did. Several composers wrote operas titled Griselda. Domenico Cimarosa wrote one called The Italian Girl in London. There's even an old folk song, a child ballad called Lady Diamond, based on Story Full.
One. Film and TV, too, I assume.
Of course. There were silent films in the 50s. Pier Paolo Pasolini's famous and controversial The Decameron film from 1971. And modern takes keep appearing, like that Netflix miniseries recently.
It just keeps going.
It really does. And what's maybe most telling is how it resurfaced during the recent COVID-19 pandemic.
How so?
Well, several projects explicitly used the Decameron as a model. Australia had Decameron 2.0. The New York Times Magazine ran the Decameron Project, commissioning new short stories. San Diego writers put together an anthology.
All inspired by this idea of storytelling during a crisis.
Exactly. People finding connection, meaning maybe just distraction, through sharing narratives when isolated or facing danger. It makes you ask, why does this specific 14th century book keep serving as the go-to model for that? What's so powerful about its premise?
That's a great question. And one last detail, Boccaccio himself drew pictures for it.
It seems so. There's a manuscript, Codex Hamilton 90, that has these elaborate drawings, and scholars think Boccaccio himself probably did them.
Wow, the author illustrating his own work.
Yeah, and those drawings likely influenced how later artists illustrated the book, too. It's a really nice personal touch, isn't it?
It really is. So when we bring it all together, the Decameron is just immense.
It really is. It's not just a bunch of entertaining, sometimes shocking stories. It's this act of literary resilience in the face of absolute devastation.
A sharp social commentary, too.
Definitely. holding up a mirror to human nature, the good, the bad, the messy. And it's clearly this incredible source, this wellspring, that just keeps feeding artists, writers, filmmakers, century after century.
So thinking about all this, what's the final takeaway for us today? What's the secret to its endurance?
Well, maybe it's not just the individual stories, brilliant as they are. Maybe the enduring power lies in the frame itself, the structure.
The 10 people telling stories to survive.
Yeah, that act. It's this testament, isn't it, to how humans, even when everything feels like it's falling apart, find comfort, find humor, find truth, maybe even find themselves in sharing narratives.
That's a powerful thought.
It really leaves you wondering, doesn't it? What are the stories we're telling each other right now, today, to make sense of our own challenging times? What's our Decameron? Have you ever found yourself, quietly thinking about existence? Or maybe just feeling that background noise, that awareness that, well, we're all mortal.
Yeah, it's not exactly light conversation, is it?
Definitely not dinner table stuff. But what if that quiet thought, the one we usually push away, is actually one of the biggest subconscious drivers, affecting our beliefs, our choices, even our health?
It's a really unsettling idea, and that's exactly what we're diving into today. We're exploring terror management theory, or TMT. It's this fascinating concept from social and evolutionary psychology.
TMT, right. Proposed by Jeff Greenberg, Sheldon Solomon, and Tom Pazinski, and their book, The Worm at the Core.
Yeah.
That lays it all out.
That's the one. The Worm at the Core, on the role of death in life. It captures the essence of it.
Okay, so let's break down this core idea. TMT says there's this fundamental conflict, right? Deep in us.
Exactly. On one hand, you've got the powerful instinct for self-preservation. We want to live.
But then, the other hand is our awareness. We know we're going to die. We know it's inevitable, unpredictable even.
And TMT argues that this clash creates a profound, almost primal terror.
It's like your brain is saying love, but also you're doomed at the same time.
Pretty much. And it's not just a fleeting thing. The theory is we manage this baseline terror through, well, various escapes, but crucially through culture, through shared beliefs.
Beliefs that kind of push back against the biological reality, that we're finite.
Precisely. They offer more enduring meaning, more value. It's all about fighting that feeling of personal insignificance that death brings, replacing it with significance from our symbolic world.
For you listening, this isn't just abstract theory. It potentially explains why we value certain things, why self-esteem is such a big deal.
How we react to health warnings, even our politics or religious views, it touches almost everything.
Our mission today is to really unpack TMT. Look at where it came from, what it implies for us, and importantly, the criticisms it's faced too. Should be some real aha moments, I think.
Definitely.
Okay, so to really get TMT, we need to rewind a bit, right, to its roots.
Absolutely.
Yeah.
I have to start with Ernest Becker. His 1973 book, The Denial of Death, won a Pulitzer. It's the intellectual foundation.
Becker's core argument was, what exactly?
He basically said that most of what humans do, most of our actions, are driven by the need to ignore or avoid the fact that we're going to die.
That the terror of just ceasing to exist creates this deep, maybe subconscious anxiety.
Exactly. And we spend our lives trying to make sense of it, finding meaning that lasts longer than our bodies.
And this isn't just an individual thing, it scales up.
Right. Societies on a larger scale respond by building these complex, symbolic systems.
Like laws, religions, cultural stories.
Yeah, all these things that explain why life matters, that provide some sense of order and permanence. These systems define what's valuable. They reward people who live up to those values.
And maybe punish or sideline those who don't fit in.
And sticking to these shared symbols, it helps ease that underlying stress about mortality.
It's a huge idea. And Becker, he was drawing on some big thinkers.
Oh yeah, a rich lineage. He expanded on Freud, though he swapped Freud's focus on sex for the fear of death as the main driver.
Interesting swap.
Yeah, and also figures like Kierkegaard, Norman O. Brown, Otto Rank. There's even that ancient echo from the Roman poet Statius.
The fear first made gods in the world line.
That's the one, back in the 1st century CE. Shows how old this intuition is.
So, from an evolutionary angle, how does TMT see this? Is it something we evolved for?
Not exactly. TMT sees it more as an unfortunate byproduct, or what biologists sometimes call an exaptation.
An exaptation. Like feathers originally for warmth, then used for flight.
Kind of like that, yeah. Our amazing cognitive abilities, problem-solving, language planning, they're hugely adaptive. But the flip side is they also make us smart enough to realize we're going to die.
So our intelligence is a double-edged sword. It helps us survive, but also burdens us with this knowledge.
Precisely. It wasn't selected for death awareness. That just came along with the high intelligence that was selected for.
And you can sort of see traces of this in early human history, like burial practices.
It's fascinating, yeah. Neanderthals might have buried their dead for practical reasons. Smell, scavengers. Pretty basic.
But later on,
By the Upper Paleolithic, burials become much more elaborate. Bodies decorated with thousands of beads, tools, food included.
suggesting belief in an afterlife, equipping them for a journey.
It strongly suggests something like that, a belief or hope beyond death. It shows how things like morality, language, ritual, maybe originally for survival, got co-opted, repurposed to manage this fundamental death anxiety.
Okay, so that's the big picture, society and evolution. But TMT really zooms in on the individual, too, specifically on self-esteem.
Absolutely central. Self-esteem in TMT terms is your personal subjective feeling of how well you're living up to the values of your culture.
It's like an internal gauge. Am I being a good person according to what my society deems good?
Exactly. And feeling like you are meeting those standards, that's what provides the crucial buffer against that existential dread. It's your personal shield.
Becker even called high self-esteem a form of heroism, didn't he?
He did. He saw society itself as a kind of codified hero system, a grand story we create to give life meaning, to defy death in a way.
But here's the twist, right? This psychological shield, this pursuit of heroism, can actually mess with our physical health sometimes.
That's the paradox, and it's a really important part of the theory. There's a model published back in 2008. It suggests, first, conscious thoughts about death. They usually make you think practically about health, like maybe I should quit smoking. Makes sense.
Right, direct threat, direct response.
But second, and this is key, unconscious death thoughts, they tend to trigger defenses focused on boosting your self-esteem and meaning, not necessarily on your physical health.
So under the surface, the priority shifts from staying healthy to feeling significant.
Often, yes. And third, if you're faced directly with your body's vulnerability, say, you find a lump that can actually undermine your symbolic defenses, make you feel anxious, and maybe even avoid seeking help because it confronts you too starkly with mortality.
Wow. Okay, let's make that concrete. The smoking example.
Right. Studies found smokers whose self-esteem is tied up in smoking, maybe it's their social identity, makes them feel cool or rebellious.
Yeah.
They're actually less likely to quit when shown anti-smoking ads focusing on death.
Wait, less likely? That seems backward.
It does, but think about it. If they accept the message, it undermines the very thing giving them self-esteem. That makes them feel more vulnerable to death thoughts. So defensively, they might even double down, feel more positive about smoking.
That's a powerful defense mechanism. Wow.
We see similar things with, say, tanning. If the cultural ideal is blondes is beautiful, reminding people of death can actually increase their intention to tan.
Because fitting the ideal boosts self-esteem, which buffers the death anxiety.
Exactly. But if the ideal shifts to pale is pretty, then the same death reminder would decrease tanning intentions. It's all about conforming to the value system that provides that self-worth.
So it seems like, especially for younger people, threats to social status might be more motivating than distant health warnings.
Often, yes. The immediate social consequences, losing face, not fitting in that, can feel much more real and pressing than the abstract idea of dying decades from now.
Okay, so these are powerful ideas.
Uh-huh.
How do researchers actually test them? You mentioned mortality salience.
Right, MS mortality salience. It's the cornerstone of TMT experimental research. The basic idea is, if culture and self-esteem protect us from death anxiety,
Then reminding us of death should make us cling tighter to our culture and try to boost our self-esteem.
precisely, it should trigger defensive responses.
And how do they? Remind people. Seems a bit grim.
It can be surprisingly subtle. Sometimes it's direct, asking people to write short essays about their own death, what they imagine will happen.
Okay.
Other times it's more indirect, conducting the experiment near a funeral home, showing brief images related to death.
And does it work? Does it trigger defenses?
The classic study, Greenberg and colleagues back in 1990, showed it clearly. They reminded Christian participants of death. Compared to a control group, they rated fellow Christians more positively afterwards and Jewish participants more negatively. Classic in-group favoritism, out-group derogation, what TMT calls worldview defense.
Wow. Just from a brief reminder.
Yeah, and here's the ticker. If they first boosted the participants' self-esteem, gave them positive feedback on something unrelated, that defensive effect, it basically disappeared.
So the self-esteem really acts as that buffer. If it's strong, you don't need to lash out defensively.
Exactly. Which leads to the related concept, death thought accessibility, or DTA.
ETA? Okay, what's that?
The idea is if you're motivated to keep death thoughts out of your mind using your worldview or self-esteem, then threatening that worldview or self-esteem should make death-related thoughts more accessible. They bubble up closer to the surface.
Like poking holes in the defense lets the anxiety leak through.
Kind of, yeah. And they measure this cleverly.
How? You can't just ask people, are you thinking about death more?
No, it's usually subconscious. They use tasks like word fragment completion. You see COFF.
Could be coffee or coffin.
Right. If death thoughts are more accessible after, say, reading an article criticizing your country, you're more likely to complete it as coffin.
That's ingenious. A subtle way to peek into the subconscious.
It is. And DTA studies help distinguish between different types of defenses. TMT talks about proximal and distal defenses.
Oh, proximal and distal. What's the difference?
Proximal defenses are immediate, conscious, rational responses to a death reminder, like deciding to exercise more or pushing the thought away deliberately. Threat-focused.
Okay, dealing with it head-on or trying to.
Right. Distal defenses are more delayed, unconscious, and symbolic. They kick in later and work by shoring up your self-esteem and faith in your worldview, believing in an afterlife, striving for symbolic immortality through achievements, that kind of thing.
So proximal is like swatting a fly. Distal is like building a stronger house.
That's a decent analogy, yeah. The dual defense model is pretty key to understanding how we cope both immediately and longer term.
And these ideas, they stretch beyond just individual psychology, right? And health politics.
Definitely. Let's touch on the terror management health model, TMHM, again. It really explores this double-edged sword of death awareness and health.
How death thoughts can motivate healthy behavior,
Yeah.
but also hinder it.
Exactly. Like the breast self-exam example. Doing the exam can consciously remind you of vulnerability, of cancer, of death. That can create fear and make someone avoid doing it.
The proximal fear-based response.
Right. But interestingly, if the death thoughts are activated subtly, unconsciously before the exam, some studies found women actually felt more empowered afterwards.
More empowered. How does that work?
The thinking is if it's unconscious, the motivation might shift towards acting in line with one's valued self-identity, like being a responsible, health-conscious person rather than just reacting to fear.
Huh. That's subtle but significant. And connecting this to society.
Yeah.
Leadership, for instance.
Yeah, TMT offers an interesting lens on leadership. Culture gives us meaning, right?
Yeah,
Buffers the terror. So when mortality is made salient, think of a national crisis. Like 9/11 people often rally around leaders who seem strong, iconic, decisive.
Leaders who restore a sense of order and purpose.
Exactly. George W. Bush's approval rating famously jumped massively after 9/11. People often prefer leaders from their own group, sometimes charismatic ones, sometimes even favoring male leaders in those moments. It's about finding security in leadership when feeling existentially threatened.
And religion fits in here too, obviously.
Hugely. TMT basically proposes religion was, in large part, created to cope with mortality.
By offering literal immortality or symbolic meaning.
Right. And research backs this up. Believing in an afterlife or just general religiosity tends to reduce those mortality salience effects like worldview defense. And reminders of death can actually increase religious belief, even implicitly in non-religious people.
A deep-seated need for that kind of ultimate meaning.
Seems so, and this spills into mental health, too.
How so?
Well, TMT researchers argue that death anxiety might be a core underlying factor in many mental health issues.
Like anxiety disorders, OCD.
Yeah. Studies using death reminders have shown temporary increases in behaviors linked to these disorders, like more compulsive hand washing after a mortality prime, perhaps a symbolic attempt to cleanse or control.
Or more avoidance in people with phobias.
Exactly. Or increased body scanning in people prone to health anxiety. The idea is these behaviors might be, in part, maladaptive attempts to manage that underlying existential dread.
It really paints a picture of death anxiety being woven into the fabric of our psychology.
It does. But like any big theory, TMT isn't without its critics. It's faced a lot of debate.
Right. It was huge in the mid-2000s a year.
Yeah.
But maybe less dominant now.
That's what some observers, like psychologist Yoel Inbar, have noted. Science constantly tests and refines ideas.
So what are the main challenges? The evolutionary one seems big. Wouldn't suppressing fear be bad for survival?
That's a key point. Fear keeps us safe, right? Why would we evolve to push away thoughts of the ultimate danger?
So how does TMT answer that?
They emphasize the dual defense model again. It's not immediate practical fear that's suppressed, you still jump out of the way of a bus. It's the gnawing existential dread that's managed symbolically through those distal defenses.
So it's about managing the abstract threat, not the concrete one.
That's the argument. But critics still say maybe these defensive reactions aren't specific to death. Maybe any threat or insecurity could cause them.
Which leads to other explanations, like coalitional psychology.
Right. This perspective suggests that when people feel threatened by anything, not just death, they naturally seek safety in groups, strengthening group identity, defending the shared worldview. That's just about building alliances for mutual protection.
Makes sense. Safety in numbers.
It does. But TMT proponents push back, saying coalitional psychology doesn't fully explain the symbolic nature of the defenses. Why allegiance to abstract ideas? Why do most cultures have supernatural beliefs, things unrelated to immediate physical safety?
It's a debate about whether it's basic group safety or something deeper, more uniquely human about confronting mortality.
Exactly. And the question remains, is it only death? Or could other bad feelings, uncertainty, pain, isolation, produce similar effects?
DMT says those things are often linked to death.
Yeah, they argue those other stressors often bring mortality to mind, linguistically or experientially, or they increase that death thought accessibility we talked about. But critics argue it's still hard to definitively prove death is the unique trigger.
Then there's the meaning maintenance model, MMM, a direct competitor.
Pretty much. MMM argues humans are fundamentally meaning-making creatures. Any threat to our sense of meaning or order, any threat, not just death, triggers anxiety and makes us try to reaffirm meaning elsewhere.
So it's broader than TMT. Death anxiety is just one example of meaning disruption.
That's the claim. But TMT folks criticize MMM for not explaining why we prefer certain meanings or why death seems to have such uniquely powerful effects across so many studies. They feel TMT is more specific and better supported by the breadth of evidence focused specifically on mortality.
What about the idea that it's not non-existence but uncertainty that scares us?
That's another angle, the offensive defensiveness idea. We just can't stand not knowing.
And TMT's response?
They acknowledge uncertainty is unsettling, sure, but they argue death isn't just uncertain. It's final and inescapable in a way other uncertainties aren't. Plus, we sometimes seek out uncertainty thrillers, exploration. We don't generally seek out death. The finality is unique.
Right, and finally, the replication issue. That sounds pretty serious for any theory.
It is. The Many Labs 4 project was a large-scale attempt to replicate various findings, and it failed to replicate a key TMT mortality salience effect on worldview defense.
It must have been a blow.
It certainly sparked a lot of discussion. TMT proponents, however, pointed to methodological issues in that specific replication attempt, sample sizes, how closely it followed the original procedures.
So the debate continues.
Absolutely. It highlights how science works, Theories are proposed, tested, challenged, refined. It's an ongoing process, messy sometimes, but crucial for advancing understanding.
So, wrapping this up, we've really journeyed deep into terror management theory today.
We have. Seeing how this often unconscious awareness of death seems to quietly influence so much, our self-worth, our social interactions, health, politics, faith.
It gives you this powerful new lens, doesn't it, for looking at why we do what we do, why cultures are the way they are, those hidden psychological gears turning.
Definitely provides some potential aha moments about human motivation.
So a final thought for everyone listening. As you go about your week, maybe reflect a little. What things do you value? What activities do you pour energy into? Could some of them, even seemingly unrelated things, actually be quiet acts of terror management? Little ways you're building your own sense of significance against? Well, against the ultimate unknown.
It's a provocative question to sit with.
Okay, so when we talk about evolution, I think most of us, our minds immediately jump to Charles Darwin, right? Natural selection.
Yeah, absolutely. It's foundational. It shaped how we understand, well, all of life's diversity.
But here's a thought. What if that story, the one about gradual change, competition driving everything, what if it isn't the whole story?
Or at least, what if for a really long time, some, well, brilliant minds were proposing completely different ways life might have changed?
Exactly. Different mechanisms altogether.
And what's so fascinating here, I think, is that these thinkers, they generally accepted that life evolves. That wasn't really the debate for many of them.
Ah, okay, so they bought into evolution happening.
Right. The core disagreement wasn't if, it was how. So today, we're not really here to debate Darwinism itself.
No.
Instead, we're going to dive into these other explanations, these alternatives for the mechanism of evolution. Some are compelling, some may be a bit surprising, and they existed right alongside Darwin's ideas, often challenging them head-on.
So that's our mission for this deep dive, then. To explore this, rich history of scientific ideas. Some physical, some maybe more philosophical.
Uh-huh. All questioning if natural selection was the only game in town, or even the main one.
We'll look at why these alternatives came up, what they were actually suggesting, and this is the really interesting part to me, how some of them, even after being kind of pushed aside by the modern synthesis,
Yeah.
they're making a comeback, finding new life because of discoveries in molecular biology. It's pretty wild.
It really is. And our source for diving into all this is a great overview from Wikipedia on alternatives to Darwinian evolution. It maps out this whole intellectual journey really well.
Perfect. So let's start by setting the stage, historically speaking. Before evolution really took hold, what was the dominant idea?
Well, you have to go way back. The prevailing view, going all the way back to Aristotle and ancient Greece, was basically unchanging forms.
Unchanging forms. So
Yeah.
species just stay the same.
Pretty much. Aristotle talked about eidos, the immutable essence of a species. It always bred true to its ideal form. This idea kind of morphed over time.
Into the great chain of being. I remember that from school.
Exactly, the stala naturae. Thinkers like Ramon Lull in the Middle Ages developed it. It depicted this fixed hierarchy of life, implying everything was set in stone from creation.
Okay, so if forms are fixed, that's a massive roadblock for any idea of evolution, not just Darwin's.
A monumental one. And then you get figures like Georges Cuvier in 1812 with his correlation of parts.
Correlation of parts. What did he mean by that?
He argued that an organism is like this perfectly integrated machine, an irreducible whole. Every part fits and works together for a specific function.
Right.
So for Cuvier, if you changed one part, the whole system would be thrown off balance. Everything else would have to change at the exact same time to compensate.
Which makes gradual single-part evolution seem, well, impossible from his viewpoint.
Utterly impossible. He couldn't see how it could work.
And isn't it ironic that Herbert Spencer, the guy who actually coined survival of the fittest, he used a similar argument against natural selection?
It's incredibly ironic. Yeah, Spencer thought it was just too improbable that all the right random variations would pop up at the same time in the right way.
So what did he think happened?
He leaned more towards a Lamarckian idea, where parts adapted simultaneously because of how they were used or not used, a more directed change.
Okay, this is key then. By the early 20th century, scientists weren't really arguing if evolution happened anymore.
Broadly speaking, no. The fact of evolution was pretty widely accepted among biologists. The real battleground was the mechanism.
It'll work.
Exactly. And Darwin's natural selection was actually, for several decades, in what historians call an eclipse. It wasn't the dominant explanation.
An eclipse of Darwinism. Why? What drove scientists to look for these other non-Darwinian mechanisms? Was it purely scientific disagreement?
Not entirely. There were definitely scientific concerns, which we'll get to, but there were other factors too. Moral and religious objections were significant for some.
How so?
Well, natural selection's emphasis on, death, struggle, randomness, competition, it just felt bleak, even immoral to many naturalists.
I could see that. It lacks a sense of purpose, maybe.
Precisely. It didn't leave much room for teleology, purpose, or design in nature, or for any sense of inherent progress in how life developed. People like St. George Jackson Mivart, Charles Lyell, they had deep reservations, often rooted in their faith.
And that idea of progress, that was a big one for others too, wasn't it? Like evolution had to be going somewhere.
Definitely. Some thinkers, like Spencer again, or the botanist George Henslow, really believe evolution was inherently progressive. Life was moving towards, higher forms.
And random variation plus selection just didn't feel directed enough to explain that perceived trajectory.
Exactly. It felt too haphazard. And then you had idealists like Edward Drinker Cope or Alpheus Hyatt, who saw these orderly patterns in the fossil record that they thought went beyond what selection alone could produce.
Okay, so philosophical and moral objections, a desire for progress. What about the scientific problems people saw with natural selection itself?
Right, there were perceived weaknesses there too. One big one was time. Could natural selection work fast enough?
Based on the age of the Earth estimates back then?
Yeah, estimates by physicists like Lord Kelvin suggested the Earth was much younger than we know now. Too young, some argued, for gradual selection to produce life's diversity.
And wasn't there a huge problem with how inheritance was understood?
Oh, absolutely. The prevailing idea was blending inheritance, like
Okay.
mixing paint offspring were just a blend of their parents.
Which would dilute any useful new trait,
Yeah,
right?
exactly. Flaming Jenkin made this point very powerfully. Any single beneficial variation would just get blended away over a few generations, making selection ineffective. Darwin himself really struggled with this.
So, faced with all these issues, moral, philosophical, scientific, did the way scientists approach biology start to shift? Maybe towards the lab?
That's a really sharp point. Yes, the late 19th and early 20th century saw this huge rise in experimental biology.
Ah.
Geneticists like Hugo de Vries, Thomas Hunt Morgan, they wanted biology to be a rigorous lab-based science. They kind of distrusted the field observations that Darwin and Wallace relied on.
Saw them as maybe anecdotal, less controlled.
Pretty much. They preferred experiments in genetics, physiology, things you could actually measure and repeat in the lab. And this focus tended to push broader, harder to test phenomena like natural selection into the background for a while.
It sounds like a fundamental shift in what counted as good science. So with all these reasons to seek alternatives, where do they look first? Inside life itself.
Many did look inward for some kind of fundamental life principle, which brings us to vitalism.
Vitalism. The idea that living things have some kind of special spark, a non-physical force.
That's the gist. A vital spirit that makes them alive, fundamentally different from just complex chemistry and physics. And this idea is ancient, goes way back.
Didn't Louis Pasteur believe something like this?
Mm.
About fermentation needing whole organisms?
He did. He thought only living yeast cells could do it, not just their chemical components. And then you had Hans Driesch's experiments with sea urchin embryos around the turn of the century.
Oh, right, separating the cells.
Yeah, he separated the first two cells, and remarkably, each one developed into a complete, albeit smaller, larva. It seemed like each cell held the entire vital capability to form a whole organism, defying a purely mechanistic view.
That does sound hard to explain mechanically. So why did vitalism fade?
Well, chemistry started providing mechanistic answers. A huge blow was Friedrich Fuller synthesizing urea, an organic compound, from purely inorganic chemicals back in 1828.
Ah, proving you didn't need a vital force from a living organism to make organic molecules.
Exactly. It showed the same chemical laws applied. As more biological processes were explained chemically and physically, vitalism just had less and less territory. By the 1930s, our sources biologists had almost unanimously abandoned it as a scientific explanation.
Okay, so if the vital spark idea was fading, did people still try to incorporate a divine element into evolution? Keep some sense of guidance?
Oh, definitely. That leads directly into theistic evolution. The basic idea is simply that a deity influences the evolutionary process somehow.
And how did people imagine that working?
There were different flavors. Asa Gray, a famous botanist and correspondent of Darwin, suggested in 1876 that God provides the beneficial variations for selection to work on, sort of subtly guiding it.
Okay.
Then you had St. George Jackson Mibart in 1871, who argued God set up preordained laws, almost like an internal program that directed evolution along certain paths. He leaned towards orthogenesis, which we'll get to. The Duke of Argyll had similar ideas about a divine plan unfolding.
But this also fell out of favor within science, didn't it? Why was that?
It really came down to the definition of science itself. By around 1900, the consensus was growing that science must rely on methodological naturalism.
Meaning?
Meaning, scientific explanations can only invoke natural, testable causes and processes. Supernatural intervention, divine guidance. These fall outside what science can empirically test or observe.
So it wasn't necessarily denying a deity's existence.
Not at all. It was about defining the boundaries of scientific inquiry. Theistic evolution, because it invoked the supernatural, failed the test, as the source puts it.
Right. So if direct divine guidance was off the table scientifically, but people still felt life wasn't just random, did they look for some kind of internal but natural direction?
Precisely. And that's where orthogenesis or progressionism comes in. This is a really fascinating one.
Orthogenesis sounds like straight line generation.
Pretty much. It's the hypothesis that life has an innate tendency to evolve in a unilinear way, moving in a specific direction, often towards greater complexity or perceived perfection.
An internal compass for evolution.
Sort of, yeah. And there were many versions. Some, like Teilhard de Chardin's, were quite spiritual. Others, like Theodor Eimer's, tried to be purely biological mechanisms, sometimes even linking it with Lamarckism.
I can see how this would appeal to paleontologists looking at fossil lineages over time.
Did it? Immensely. It was very popular among paleontologists, like Henry Fairfield Osborn at the American Museum of Natural History. They looked at the fossil record and saw what they interpreted as clear, straight-line trends.
Like the Titanidae horns Osborn studied.
Exactly. He argued these horns showed orthogenetic trends. They just kept evolving in a certain direction, seemingly independent of whether it was adaptive or not. Sometimes, he argued, these trends even became detrimental.
The classic example being the Irish elk's enormous antlers.
That's the one. Osborn and others suggested those huge antlers were an orthogenetic trend that just kept going, possibly even contributing to the elk's extinction because they became so unwieldy beyond any adaptive advantage.
So this idea of an internal, pre-programmed evolutionary track, why did it eventually lose favor, especially when the modern synthesis came together?
Support really dropped off during the modern synthesis in the 1940s. The big problem was that orthogenesis couldn't easily explain the actual pattern of evolution revealed by the fossil record and genetics.
Which isn't a straight line at all.
Not at all. It's a branching bush, incredibly complex diversification. Natural selection combined with genetics could explain that branching pattern much better than a theory based on inherent linear trends.
But you hinted earlier, is there a sense in which orthogenesis, or something like it, is seeing a bit of a comeback?
In a way, yes, but it's quite different now. Not the old mystical or purely linear idea. Modern work in the 21st century talks about constrained orthogenesis.
Constrained orthogenesis, okay, what does that involve?
It looks at things like mutation bias, the idea that mutations aren't entirely random in their effects. Some types might be more likely than others. And it looks at developmental constraints, how the process of embryonic development itself might channel evolution down certain paths.
So it's not an internal drive, but more like the available roads for evolution are limited or biased by the underlying biology.
That's a great way to put it. Self-organizing principles in development, the structure of the genome. These things might make certain evolutionary outcomes more probable than others, creating preferred directions without invoking any mysterious forces. It's orthogenesis reimagined through molecular and developmental biology.
That's really fascinating. Okay, so moving away from internal drives and directions, let's talk about how characteristics were thought to be inherited, which brings us inevitably to Lamarckism.
Yes, Jean-Baptiste Lamarck. His 1809 theory is probably the most famous alternative. The core idea is the inheritance of acquired characteristics.
So traits developed during life, stronger muscles from use, weaker organs from disuse, could be passed on to offspring.
That was the idea. A giraffe stretching its neck to reach higher leaves would pass on a slightly longer neck, and so on, generation after generation. It was part of his larger view of progressive evolution, too.
What always surprises me is that Darwin himself didn't completely dismiss this. Didn't he include a section on use and disuse in the origin?
He absolutely did. Chapter 5, Laws of Variation, includes effects of the increased use and disuse of parts. He cites examples like ground birds having stronger legs or ostriches having weaker wings because they don't fly. So the idea had real currency.
And it wasn't just Darwin entertaining it. Who else supported this neo-Lamarckian view?
Oh, it had significant proponents in the late 19th century. People like Ernst Haeckel, Edward Drinker Cope, who we mentioned earlier, and Alpheus Packard. Packard used it to explain things like how cave insects lost their sight over time through disuse.
Makes intuitive sense in a way. George Henslow, the botanist, even thought environmental stress could directly cause inheritable changes.
Right. He focused on variations caused by the environment itself.
So, given its intuitive appeal and proponents, what led to Lamarckism's decline as a major scientific theory?
Two main things, really. First, a persistent lack of convincing experimental evidence. People tried, but demonstrating the inheritance of acquired traits proved incredibly difficult, if not impossible.
And the second thing, was it theoretical?
Very much so. The big blow came from August Weismann and his germplasm theory around the 1880s.
The Weismann barrier.
Exactly. Weismann argued there's a strict separation between the body cells, soma, and the reproductive cells, germline, sperm, and eggs. Changes acquired by the body, like bigger muscles from lifting weights, couldn't affect the germ cells.
So they couldn't be passed on to the next generation.
Precisely. If you cut off a mouse's tail, its offspring are still born with tails. The acquired change doesn't enter the hereditary information. This theoretical barrier made traditional Lamarckism seem biologically impossible for animals, at least.
Yet, we hear about epigenetics now, which sounds a bit Lamarckian. Is there a connection, or is it fundamentally different?
There are echoes, but it's crucial to understand the difference. Epigenetics studies heritable changes in gene expression, how genes are turned on or off that don't involve changes to the underlying DNA sequence itself.
Okay, so it's not changing the blueprint, just how the blueprint is read.
That's a good analogy. And these epigenetic marks can sometimes be influenced by the environment and can, in certain cases, more clearly in plants and microbes, sometimes in animals, be passed across a generation or two.
But it's not the same as Lamarck's idea.
No. It's generally not seen as directing large-scale evolutionary change in the way Lamarck envisioned. These changes often aren't permanent over many generations, and they don't directly contradict the Weismann barrier in the way originally conceived. It's a fascinating layer of complexity, but not quite Lamarckism reborn.
Got it. So if inheriting acquired traits was out, what about evolution happening in big jumps? Not gradual change, but sudden, large mutations creating new forms.
Ah, yes, that brings us to saltationism, or mutationism. The idea that new species pop into existence rapidly through major mutations, rather than Darwin's slow accumulation of tiny variations.
Sounds traumatic. Who was pushing this idea?
It was particularly popular among the early geneticists around the turn of the 20th century. Figures like Hugo de Vries, one of the rediscoverers of Mendel's work, and William Bateson in the UK. Even Thomas Hunt Morgan, who later became a pillar of the modern synthesis, initially favored large mutations.
And de Vries's work with evening primroses seemed like strong evidence, didn't it? He found new varieties appearing suddenly.
It did seem like it at first. He observed these Anothera plants throwing off new forms, some quite different, single generations. He called them mutations, and thought this was how new species arose.
But that turned out to be something else.
Yeah, later work, especially by Hermann Joseph Müller, showed that de Vries's mutations were mostly due to polyploidy changes in the number of whole chromosome sets, or complex chromosome rearrangements, not single gene mutations causing huge effects.
And Morgan's work with fruit flies.
Morgan's detailed experiments with Drosophila showed that most mutations actually cause small effects, behaved according to Mendelian rules, and spread through populations via natural selection. This shifted the focus back towards gradualism, powered by small mutations.
So the idea of a single monster mutation creating a new species overnight was largely dismissed. But is there any sense in which saltation, big evolutionary jumps, is relevant today?
Oh, absolutely, just not necessarily via single gene mutations. Modern biology recognizes several mechanisms that can cause rapid, significant evolutionary change.
Like what?
Well, polyploidy, like in de Vries's primroses, is actually a major mechanism of speciation, especially in plants. Gene duplication can instantly provide new genetic material for evolution to work with. Lateral gene transfer genes jumping between different species is huge in microbes and even happens elsewhere.
And things like jumping genes.
Transposable elements, exactly. They can move around the genome and cause significant changes. And think about the endosymbiotic theory, the origin of mitochondria and chloroplasts from engulfed bacteria. That's a massive saltational leap through symbiogenesis, the merging of organisms.
So big leaps do happen, just through different mechanisms than originally thought.
Yeah.
That's a great example of an old idea finding new relevance. Okay, so we've covered internal forces, inheritance. What about external events shaping life's history? Or maybe inherent principles of design?
Good transition. Let's start with the external, catastrophism. This goes back to Georges Cuvier again, around 1812.
Right, his idea that extinctions and changes in the fossil record weren't gradual, but caused by big, sudden natural disasters.
Exactly. Things like huge volcanic eruptions, massive floods, wiping out existing life in an area which would then be repopulated, possibly by migration from elsewhere, leading to the faunal succession seen in rock layers.
And it's important, as you noted, Cuvier explained this through natural catastrophes, not necessarily invoking divine intervention like Noah's flood for each one.
Correct. He saw evidence for multiple recurring natural catastrophes in the geological strata.
This idea was overshadowed for a long time by uniformitarianism, Lyell's idea of slow, gradual geological change being the norm. But catastrophism made a comeback, didn't it?
A huge comeback. The discovery of the Cretaceous-Paleogene extinction event really cemented its place in modern science.
The dinosaur killer.
That's the one.
Mm-hmm.
The hypothesis by Walter and Luis Alvarez in 1980, proposing a massive asteroid impact 66 million years ago, caused a global catastrophe and mass extinction.
And then finding the Chicxulub crater in Mexico as the smoking gun.
Precisely. It showed that major catastrophic events do happen and can profoundly reshape the course of life on Earth. It's now a standard part of our understanding.
Okay, so external catastrophes are one factor. What about internal principles of form or structure? That brings us to structuralism, right?
It does. Biological structuralism offers a different kind of challenge to pure Darwinism. It suggests that the forms life takes aren't just shaped by natural selection acting on random variation, but are also guided or constrained by physical laws, principles of organization, and developmental processes.
So it's not denying selection necessarily, but saying other factors related to form itself play a key role, maybe even primary sometimes.
That's often the argument. It has historical roots in thinkers like Etienne Geoffroy Saint-Hilaire, who talked about shared homologous parts across animals, or Darcy Thompson in his amazing 1917 book on growth and form.
Thompson used mathematics and physics to explain biological shapes, didn't he? Showing how forms could be transformed geometrically.
Yes, suggesting underlying physical and mathematical principles constrain the forms organisms can take. It's less about optimal adaptation and more about what forms are physically possible or likely to emerge.
Who are some more modern proponents or key ideas within structuralism?
Well, you have diverse ideas. Adolf Seilacher proposed mechanical inflation to explain strange Ediacaran fossils. Günter P. Wagner emphasizes developmental bias, how the way organisms develop biases, the kinds of variations that can arise.
And Stuart Kaufman talks about self-organization.
Right. The idea that complex structures can emerge spontaneously from the interactions of parts, following simple rules, without every detail being specified by genes and selected for. Eilenton talks about inherent laws of form, almost like Platonic types.
Then there's Gould and Lewontin's concept of spandrels.
Yeah.
Architectural byproducts.
Exactly. Features that arise as necessary consequences of an organism's overall structure or development, not because they were directly selected for a specific function. Like the space under an arch, it's just there because of how arches are built.
So a feature might exist not because it's adaptive, but just because it's linked to something else that is, or it's just how development works.
That's the idea. Gerd Muller and Stuart Newman even suggest that early evolution, like during the Cambrian explosion, might have been more pre-Mendelian, driven by physical mechanisms and environmental responses before genetic control became so dominant. Brian Goodwin argued pattern formation comes from morphogenetic fields, denying you can reduce complexity just to selection.
It's a very different emphasis. How do mainstream Darwinian biologists respond to these structuralist arguments?
They certainly acknowledge that physics and development place constraints. Things like cell membranes self-assembling are clear examples of self-organization. But they generally argue that while these factors set the boundaries of what's possible, natural selection acting on genetic variation is still the primary engine driving the specific, complex adaptations we see across the vast diversity of life. They question if structuralism alone can explain that level of fine-tuned adaptation.
Okay, that makes sense. Now let's shift perspective again, down to the molecular level. How does something like genetic drift fit into this picture of alternatives, specifically the neutral theory?
Right, the neutral theory of molecular evolution. Proposed by Motoo Kimura in 1968, this was a really big deal.
What's the core claim?
Kimura argued that most evolutionary changes at the molecular level, changes in DNA sequences, protein sequences, and most of the variation within species at that level, are caused by genetic drift acting on neutral mutations, not by natural selection acting on advantageous mutations.
Okay, unpack neutral mutations and genetic drift for us.
Sure. A neutral mutation is a change in the DNA that doesn't really affect the organism's survival or reproduction. It's neither helpful nor harmful. Maybe it changes a protein slightly in a way that doesn't alter its function, or it occurs in non-coding DNA.
So selection doesn't see it.
Exactly. And genetic drift is basically just random chance in survival and reproduction. In any generation, purely by luck, some individuals might leave more offspring than others, regardless of their genes. Over time, this random sampling can cause gene variants, including neutral ones, to increase or decrease in frequency, or even become fixed or lost just by chance.
So Kimura was saying most molecular evolution is just random noise.
That's a way to put it. The 1969 paper by King and Jukes, provocatively titled Non-Darwinian Evolution, really pushed this idea using comparisons of protein sequences across species, arguing the patterns looked more like random drift than selection. It sparked a huge debate.
Non-Darwinian. That sounds like a direct challenge.
Hmm.
Did Kimura see it as replacing Darwinism altogether?
No, and this is really important. Kimura himself was very clear that his theory applied primarily at the molecular level. He still believed that evolution at the level of the phenotype, the organism's observable traits and adaptations, was largely governed by natural selection.
Ah, so it wasn't an alternative for all evolution, just for what's happening under the hood genetically.
Precisely. It describes a crucially important evolutionary mechanism, especially at the DNA level, but it complements rather than replaces natural selection, which still shapes the organism's interaction with its environment.
Okay, this has been a whirlwind tour through so many different ideas. It raises a question, though. Did scientists back then typically pick just one of these alternatives to champion against Darwin? Or was it more mixed?
That's a fantastic question, and the answer is often. It was much more mixed and complex. These ideas weren't always seen as mutually exclusive. Many thinkers actually blended elements from several different evolutionary philosophies. It really highlights how dynamic and, frankly, messy the intellectual landscape was before the modern synthesis created a more unified, though not monolithic, framework.
Can you give us an example of someone who really wove these different threads together?
A perfect case study is the American paleontologist Edward Drinker Cope. He's fascinating. He started out denying evolution, but by the 1860s, he accepted it, but became a fierce opponent of natural selection as the main mechanism.
Okay, so what did his theory look like? What did he mix together?
Oh, it was quite a cocktail. He incorporated recapitulationism, the old idea that an organism's development mirrors its evolutionary history.
Ontogeny recapitulates phylogeny.
That's the one. He saw this as evidence of a preset plan, which led him directly to orthogenesis. He believed evolution followed fixed, regular patterns, often non-adaptive steps that were part of a larger design.
So a bit of theistic evolution in there, too, with the divine plan idea.
Definitely. He believed in an underlying divine plan guiding the orthogenetic trends. But then, to explain how organisms moved along these preset tracks, he brought in Lamarckism.
Use and disuse driving the changes.
Yes.
Functional adaptation through the inheritance of acquired characteristics was, for him, the mechanism that pushed life along the orthogenetic pathways laid out by the plan.
Wow. Recapitulation, orthogenesis, theism, Lamarckism, anything else.
Yes. He topped it off with his own unique version of vitalism. He called it bathmism.
Bathmism.
It was his concept of a vital growth force within organisms. He thought this force could be consciously or unconsciously directed and concentrated by use and disuse into certain parts of the body, causing them to develop, perhaps at the expense of other parts.
Good grief. It's a lot of different ideas rolled into one. It really is. Cope's view perfectly illustrates how thinkers before the synthesis could weave together recapitulation, orthogenesis, theistic evolution, Lamarckism, and even vitalism into a single, complex evolutionary philosophy that explicitly rejected natural selection as the primary driver. It shows just how diverse the thinking was.
Wow. Okay. That was genuinely a deep dive. It's incredible to think about how many different ways these brilliant scientific minds tried to grapple with the sheer complexity and diversity of life. So many different roads explored before natural selection really took center stage.
It's fascinating. And while the modern synthesis did bring natural selection, combined with genetics, back to the forefront, what's so striking is how elements of these older alternative ideas keep resurfacing in new forms.
Right, like you mentioned with constrained orthogenesis or epigenetics having Lamarckian echoes.
Exactly. And catastrophism is now mainstream. Structuralist ideas about developmental constraints are highly relevant, and even saltationism finds echoes in things like polyploidy and gene transfer. It's not a return to the old theories wholesale.
No, not vitalism or anything.
Definitely not, but it shows that the mechanisms driving evolution are perhaps even richer and more varied than the strictest interpretation of the synthesis might have suggested. Molecular biology has opened up complexities that touch on these older themes in new ways.
And yet, despite biology embracing this selection-driven framework, our source makes a really interesting final point. It notes that a belief in some kind of inherent progress, a sort of leftover orthogenetic idea, still lingers, not just in the public mind, but maybe even subtly among biologists.
It's a provocative thought. The philosopher of science Michael Ruse has suggested this might stem from our human tendency to seek meaning, or perhaps we project our own sense of scientific and technological progress onto the natural world.
Hmm. So here's something for you, the listener, to mull over. Is there an inherent direction or progress in evolution? Or is that something we impose on the story? As you think about this deep dive, consider how our very human desire for narrative, for purpose, maybe even for progress, might shape how we interpret the sprawling, branching, and often surprising history of life on Earth.